So the way that these work is that you are going to grab the S values off the chart, that thermodynamics chart, and then you're going to subtract the total of this side from the total of this side. And the other thing you need to know is that the values on the chart are for just 1 mole of something. So when there's a 2, you're going to have to multiply each of the S terms by the coefficients, because it doubles the amount of energy associated if you have more than 1 mole of something. So let's fill in these numbers and get going. Again, don't forget that you can do Control F to help you find something. So right here, I'm almost at carbon. And as I'm looking, there's my CH3. Notice there's 2 options for OH. It's the top one that I want. And the first column is H, the second column is G, and I'm trying to get to go over and show me the last one. 126.8. And if you go to the last video, you'll be reminded that that is the unit. And before I move on from carbon, I'm going to do the CO2. So CO2 as a gas, again, I gotta go over, is 213.8. Now, oxygen, if this were talking about just the enthalpy, the H term, then I could immediately just say oxygen was 0 because it's an element, and in the standard state, we find it as a gas. So for entropy, that would be, for enthalpy, that would be true, as well as spontaneity. But as we're looking at this term, it's not ever 0. So I'm trying to get on to I scrolled past my oxygens. So silver, so there's my oxygen. So that one is 0, 0, but look, 205.2. And then my last thing in here is water. So I need to scroll up to my hydrogens. It's water as a liquid. There we go, water as a liquid, 70. So then I need these terms here, and it's basically like you're adding these 2 together and adding these 2 together, but you're subtracting this whole thing from that side. And to help you not actually make a mistake, because I have so helped someone with this, and I have accidentally not done it this way, and have made a mistake with it. So I like to put, oops, let me see if I can get a little less than that. Copy. There we go. I like to put my S of my reaction, because I'm trying to figure out my whole S of my reaction. I like to write it like under the arrow intentionally, so that when I start to write it out, my first numbers are right above it. Those are my first numbers that I need. And then these ones are my second numbers that I need. I'm going to have to make them a little smaller to fit them in there. I'll make that just a little smaller. There we go. I have to put a parentheses around it. So I'm going to zoom in so that you can see that better. This will get us to the SF reaction. These, by the way, were SF formation values. SF formation, SF formation, SF formation. I'm going to come over here. So 2 times 2, 1, 3.8 plus 4 times 700 minus parentheses 2 times 126.8 plus 3 times 205.2. And that gives me that my S of my reaction is 2358.4. And my units on that were joules per mole Kelvin. And just note, if I actually had to do something with this term and like add it to H or something like that, I could have converted my units, divided by 1,000 joules in 1 kilojoule. And that would have gotten me, if I had needed it that way, that would have gotten me to 2.3584 kilojoules per mole Kelvin, if that had been needed. I'm just pointing it out because in the future it will be needed.